Hi there, young chemist. You're welcome to class today. In today's lesson, we'll be discussing solubility of solute. Okay, and we'll look at the meaning of the word solubility as it has to do with solutes, and then we'll also look at calculation of solubility, how to calculate and determine solubility of common solute. Okay. Before we go deeply into the lesson, let's do a recap of what we already learned about solution, solute, and solvent. Okay, it is important that we do this recap to understand how solutes are related to solvent. Okay, let's get into it quickly. So, in previous lessons, we have learned about solute being the substance that is being dissolved in solution, and while solvent is the substance that dissolves the solute. And then we also have learned that solutes are always present in lesser amounts compared to solvents, which are always present in greater amounts. Okay, solutes and solvents can be in any of the three physical states, but solutes are usually solids while solvents are usually liquid. Okay, and then they form a homogeneous mixture called solution. So the next thing we're going to look at quickly is the classification of solution according to the amount of solute present in it. Solution can be classified based on the amount of solute present in that solution. And then we can classify solution into three major types. Okay, we have the first one we call the diluted solution, and then we can either call it concentrated solution, and then we have the third type, which is the saturated solution. This diluted solution can otherwise be called unsaturated solution. It is unsaturated solution, but our focus for this lesson will be on saturated solution, and that's because it is important in determining the solubility of any solute. And what does it mean to be saturated? What does it mean for a solution to be saturated? It basically does mean the solution is completely filled with the maximum amount of solute it can take at the stated temperature. So as you can see from the slide, it's a solution that has the maximum amount of solute possibly dissolved already in a solvent. So what it means is that at a particular temperature, a saturated solution can no longer dissolve any more solute. Okay, so no solute can be dissolved by a saturated solution at that temperature. Right, so here's a very quick question for you to think on. If a saturated solution can't dissolve any more solute, what could be done to the solution to enable it dissolve more solute? What could be done? What could be changed to make the solution dissolve more solute? Think about that and let me know what your answer is in the comment section. Okay, so let's go ahead and look at solubility. Okay, right, solubility is measured as the maximum amount of solute that can be dissolved in a specified amount of a solvent. Okay, this sounds like saturated solution, right? Yes, that's because in determination of solubility, it is important to first of all prepare a saturated solution of that solute. So if you want to know this, how soluble a particular solute, say for example sodium chloride, is in water at a particular temperature, we would need to first of all prepare a saturated solution of sodium chloride in water at the given temperature. Now, the amount of solute that it takes to prepare that saturated solution is used to express the solubility of the salt. it is usually expressed in mole per dm cube. As mentioned there, it is usually measured in mole per dm cube, but of course can be measured in other units like gram per dm cube or gram per cm cube and the other of its like. And note that 1 dm cube is equal to 1000 cm cube. Okay, so 1 dm cube is equal to 1000 cm cube. So the specified unit, the specified amount of solvent that is considered for measuring the solubility of any salt is 1 dm cube, okay, or 1000 cm cube. So once again, remember that solubility measures the maximum amount of solute that is needed to saturate a dm cube of solvent, or you can say 1 volume of solvent at a particular temperature. It is temperature dependent. It depends on temperature. Right. So we're going to look at some example, but first let's discuss how to determine the solubility of a salt. Okay, I'm saying salt because most solutes that are considered are actually salt. So I'm going to show a few examples of saturated solutions. As you can see, these are examples of solutions that are saturated by solute. This solution can no longer dissolve any more solute. Okay, that's because they have dissolved at this temperature the maximum amount of solute that they can take, that the solvent can hold. Right? And don't forget, the first thing you need to do for this video is to find out how can a saturated solution be made to dissolve more solute. What can be done to make a saturated solution dissolve more solute? Think about that and let me know what you have in the comment section. Now, moving on, we can see that for most solutes, the solubility increases as temperature also increases. This is a table of common solutes in the laboratory. Okay, these are common solutes. All of these are soluble in water, and then what is common to all of them is that as temperature increases, they tend to dissolve more. Okay, and that's true for most solutes, and that is why you will find out that hot water is a better solvent than cold water. Right? You are going to tell me why. Find out and tell me why. Do a research and tell me why. Why is hot water a better solvent compared to cold water? And then try out this assessment also. Okay, so you have 2 assessments already. First of all, how can a saturated solution be made to dissolve more solute? And second of all, why is hot water considered to be a better solvent than cold water when compared to cold water? Okay, now so it has been experimentally determined that to take this amount of potassium trioxynitrate 5 to saturate 1 dm cube of water. So at 25 degrees Celsius, please take note, the temperature at which this is achieved is 25 degrees Celsius. So it will take 403 grams of the salt to prepare a saturated solution. Remember, that is what is required to find solubility, but the only difference is that solubility is measured in moles, and this has been given us in gram. So quickly pause this video and think of how to convert this to moles to get the solubility in moles. As you can see, this is simply done by dividing the mass given by the molar mass. Okay, since that is the amount that is required to prepare a saturated solution of 1000 cm cube, we simply divide that by the molar mass of the compound, and that gives us 3.99 moles per dm cube. We're going to solve more examples in the live section. Stay safe and be good. See you in class. Bye.